So the last question of paper 6 is about planning experiment, which is usually 6 to 7 marks. So it's having a greater weightage in your paper 6. We did first 4. Today's question 5. The, the experiment is we have to plan an experiment like metal ring can be coated with a layer of copper using electricity. Like we can use electrolysis for coating of the substance. And remember, this electrolysis can only be used to electroplate the metals which are lower in reactivity below hydrogen. Elements which are above hydrogen, so if you use your aqueous solution, the hydrogen will move instead of those elements, so we cannot electroplate. So electroplating can only be done for metals which are low in reactivity by this method. We have to plan an experiment to electroplate a small metal ring with copper. So there's a metal ring which we want to electroplate with copper. You are provided with a common lab apparatus, and a copper rod is there, a copper 2 crystals are there, and a water is there, and a small metal ring. So the things which are available for us, we have crystals of copper sulfate, okay? And we have a water is there, we have a small metal ring is there, and we have a copper rod. So for electroplating, what we should do, and include a label diagram in your answer. So drawing a diagram also having marks here. So first I will start with a diagram. So first we'll take a copper rod and we'll take a beaker or a container and we fill this container with water. After filling it with water, what we will do? We will add crystals of copper sulfate and we dissolve them. So when we dissolve them, so this will become the solution of copper to sulfate, because we don't have a solution. We have crystals and water. So this is aqueous copper to sulfate, CuSO4. Here we have a copper rod and the ring which we want to electroplate. Example, we want to electroplate this ring. Now for electrolysis, we should use the battery or a cell. So the copper will be connected to positive terminal and the ring is connected with a negative terminal. So copper rod is actually anode and the ring is actually a cathode. So when we do this electrolysis, when we switch on the circuit, so we have in the solution, because it's an aqueous copper 2 sulfate, so it contains copper ion, it contains sulfate ion, it contains hydrogen ion and hydroxide ion. Because copper is less reactive ion, so copper ion will move towards the cathode. When the copper ions will move towards cathode, they will gain electron and it will turn into copper atom. And these copper atoms will stick to the ring. So ring will have a layer of copper. And to overcome this, because this rod is made up of copper, so copper atoms from the anode will go inside the solution and turn into copper ion. And the size of the anode will start to shrink, decrease as atoms turn into ion, and size of the cathode start to increase as ions turn into atoms. So this is how it should be, all things should be labeled. I should label anode, cathode, battery, electrolyte. We cannot use graphite. If you use a graphite, it won't last for a longer. Like example, if you use a graphite here, then copper ions will move there and it will stick to this. But maybe the electrolyte may not have sufficient amount of copper ions. So it may not have a equally like uniform layer of the copper. To make sure we have excess of a copper, that's why anode should be made up of copper. So if you use graphite or platinum as an anode, then this method, because the copper ions will move, but the amount of the copper ions will be less. As a result, we may not have a complete electroplating of the cathode, the ring. So What we should do, how we should carry out this experiment. First thing, because we want the solution, so we will add crystals of copper 2 sulfate in water and make aqueous solution. So we add crystals of copper 2 sulfate in water and we make an aqueous solution. That's the first thing we do. Whenever we want to electroplate, the material should be clean. Like it should not have any other, because usually what happens when metallic objects are there, they may develop an oxide layer. So what we should do, we should make it very clean. So how we can clean? So we can clean the ring by using sandpaper. Because the sandpaper is having a rough surface, so as a result, maybe you have seen a sandpaper is used for even before painting a wall. The sandpaper is used to remove any previous color. So as a rough paper is there, when the object is rough, as a result, any unwanted material is there that can be removed. So like it will polish the surface. So we clean the ring by using a sandpaper. Then we connect copper rod as to the positive terminal, or you can also say anode. And the ring is connected to cathode. Then we'll pass the electricity. And for a uniform uniform electroplating, what we should do, we should rotate the ring continuously for uniform electroplating. Then what at the last, what we should do, we should remove the ring. Then we should wash and dry. You can mention wash with a distilled water and dry with a tissue paper. You can mention that point as well. What will happen if we don't rotate the ring? It may have a non-uniform layer, like one side may have a more copper than the other side. So the thickness of the thickness of the layer, the copper plating, as we are doing a copper plating, so one side may have more copper than the other side. That's why we should continuously rotate. No, we don't have to explain. Remember, yeah, that's a good question. We don't have to explain the whole process. We don't have to write any equation for that, because this is just a planning experiment. So you are supposed to just mention how it can be done. You are not supposed to explain chemistry behind it. Is it clear to everyone? Why specifically we use copper sulfate? Because in the question, they give us the copper sulfate crystal. That's why we use copper sulfate. And those crystals which are soluble, we can use them to make a solution. So if we use any compound of a copper which is insoluble, it won't work. That's why copper sulfate is used.